Welcome to another lesson by BeWell, shaping the health and care workforce of tomorrow. The BeWell project addresses the need to prepare the health and care workforce for green and digital solutions introduced in the European health and care systems to ensure they can respond to current and future challenges. Applications and criticalities are crucial aspects in the implementation and management of the system. Let's delve into them together.
So, let's talk about examples, applications, and criticalities. A computer system of this size is subject to various critical issues, many of which, if not adequately assessed, can lead to system downtime. There are several aspects that need to be carefully evaluated, specifically activity volumes, annual data traffic size, management of exams with high data size, exams with additional processing increase their data quantity in bytes, high demand for performance, both appropriate and inappropriate, image retrieval and display time. The analysis of these specifications aims to design storage and network systems with high performance and cost-effectiveness. One of the most important aspects of PACS is the ability to provide all images wherever and whenever they are needed. This objective is best achieved by storing the majority of images on spinning disks, such as a redundant array of independent disks, RAID, sold in advanced configurations known as Network Attached Storage (NAS) and Storage Area Network (SAN). Despite advancements in storage and transmission technologies, image compression is indispensable as it reduces not only storage requirements but also study transmission times. Lossless compression is typically used on all images before the reporting phase, as it does not change the image in terms of pixels and dimensions. After diagnosis, lossy compression can be applied to images stored in fast memory, while losslessly compressed images are stored in less expensive long-term archives. The hierarchy and structure of memory are of fundamental importance. It is possible to store data in different modes as described earlier, and it is crucial to mention the memory hierarchies involved in these large-scale computer systems. Online storage. This level of storage allows rapid access to diagnostic exams with a high probability of access, around 80 to 90%. It includes images currently being processed, under execution, or awaiting reporting, or those associated with exams performed in the previous months, requiring minimal access times on the order of seconds. Nearline storage. This scalable and cost-effective storage level is used to store large volumes of data. The probability of accessing exams in this level is around 20 to 10%, and it includes images used for screening procedures, such as mammograms. Lossless compression techniques are utilized at this level. Storage is performed on NAS servers, DLT libraries, or jukeboxes, allowing exam viewing within minutes. Offline storage. Data in this storage level is rarely accessed and is primarily used as a historical legal archive. Accessing this data is very slow, taking hours or days, often through manual means. Exams are stored on optical CD-DVDs or tapes and kept in dedicated shelves. In this table provides a concise overview of the above-mentioned information. There are numerous storage methods, and today's technology offers many possibilities, among which the cloud stands out. It is indeed possible, if properly designed, to use the cloud as a repository and storage for medical images. This possibility has advantages and disadvantages, whether it is designed for a public or private site. In public sites, there is a clear advantage in terms of data sharing within the facility, making it possible to view exams and reports in any department. However, this can have a negative impact on image viewing policies, privacy, and the required bandwidth. Similarly, in private sites, cloud storage can be secure and easy to manage, but it may involve high acquisition and maintenance costs with the risk of making the system obsolete. A process is an organized set of activities and decisions aimed at producing defined outputs based on defined inputs. A process-oriented organization is a collection of processes aimed at preparing the product, service for the end user. Discrete event systems are characterized by a discrete state space that is not necessarily numerical. The dynamic behavior of such systems is driven by the occurrence of discrete events, which occur irregularly and may not be known in advance, resulting in instantaneous state changes. The activities identified by the events are typically concurrent and require synchronization and control strategies. Significant examples can be found in manufacturing processes, electronic computer networks, transportation networks, and communication systems. This method of process analysis allows for modeling and optimizing the flow of events that occur in a hospital department. In this case, the analysis focuses on the radiology department. Radiology workflow was analyzed in detail, utilizing the aforementioned concepts related to department analysis. By combining these concepts with graphical modeling tools, it is possible to model the entire department. The figure summarizes the model under examination. Given the department structure, including the localization of points of interest such as reception, modalities, reporting rooms, data flow, and diagnostic activities, it is possible to analyze events by generating a discrete event model. The typical representation of such a model is shown in the figure. The modeling is based on variable data, which allows for a detailed analysis of flows and their variations. The study at hand produces output data, which can provide crucial information about the processes and their characteristics, such as waiting time for an examination or utilization time of the IS packs. When adequately processed, this information can be the key to process optimization. By varying the structure of the model, different results can be obtained, which is why it is possible to structure the department in such a way as to avoid the issues highlighted by the data analysis. It is evident that the comparison between different modeling approaches proposes the optimal solution.
In this lesson, we have made an initial approach to how to manage the RIS/PAC system. It has been useful as a foundation and model for addressing potential critical aspects more effectively. Thank you, and see you in the next one.